लास्ट लेक्चर में हमने कहाँ तक क्लियर किया था? हाइब्रिडाइजेशन, we have completed representation of organic compounds and DU. Now we will go to classification, how organic compounds are classified. Classification of organic compounds. Organic compounds are classified into open chain compounds are acyclic compounds. Second is closed chain compounds are cyclic compounds. Closed chain or cyclic compounds are further of two types: alicyclic compounds and aromatic compounds. They are further differentiated into two types. Alicyclic compounds are homocyclic and heterocyclic, and similarly aromatic compounds are differentiated into homocyclic and heterocyclic. Now we will learn each of them individually. So organic compounds are classified into two types. Open chain compounds are acyclic compound without any cyclic ring. They are open chain compounds. They may be citrate or branched. Second is closed chain compounds are cyclic compounds. These compounds contain cyclic rings, right? Now cyclic compounds are further differentiated into two types: alicyclic and aromatic. What are alicyclic compounds? These are further of two types: homocyclic, heterocyclic. Similarly, aromatic compounds are further of two types. First is homocyclic and heterocyclic. I will give you a brief introduction of each. First of all, we will go to this type that's called open chain compounds or acyclic compounds. What are open chain compounds or acyclic compounds? Open chain compounds or acyclic compounds are those compounds which do not possess any cyclic ring. They are in open chain form. They may be branched or straight line. क्या है? ऐसे कंपाउंड जिनमें कोई भी साइक्लिक रिंग स्ट्रक्चर नहीं होता, ये ओपन चेन फॉर्म में होते हैं. ये स्ट्रेट या ब्रांचेड हो सकते हैं. राइट इट अप. द फर्स्ट टाइप ओपन चेन और acyclic compounds. Compounds in which the carbon atoms are linked to each other. Compounds in which the carbon atoms are linked to each other in such a manner that molecule possess an open chain structure. That the molecule possesses an open chain structure. The carbon atom may be straight chain or branched. The carbon atom may be straight chain or branched. May be straight chain or branched. इनका दूसरा नाम है, इनको एलिफैटिक कंपाउंड्स भी कहा जाता है. They are also called aliphatic compounds. Write it down. They are called aliphatic compounds. They are also called what compounds? Aliphatic compounds. For example, let me take an example. A few examples are this. Is this an open chain compound? Clear? Is it linear or branched? Straight chain? I will take one more example. For example, if is it branched? Both are open chain. This is straight, this is branched, and they are aliphatic compounds are open chain or acyclic compounds. Clear? Now after that we will move to closed chain or cyclic compounds. What are closed chain or cyclic compounds? These are those organic compounds which contain closed rings. What? ऐसे कार्बन कंपाउंड जिनमें क्लोज्ड रिंग्स होती है. ठीक है ना? अब ये या तो होमोसाइक्लिक हो सकती है या तो हेटेरोसाइक्लिक हो सकती है. व्हाट इज होमोसाइक्लिक? व्हेन ईच मेंबर ऑफ द रिंग इज अ कार्बन. एंड व्हाट आर हेटेरोसाइक्लिक? In addition to the carbon, there must be a heteroatom present in the cyclic ring, and the heteroatom which are present, they usually include nitrogen, oxygen, sulfur. Clear? Write it up. Closed chain or cyclic compounds. these compounds contain one or more cyclic system in their molecules. One or more cyclic system in their molecules. They are further differentiated into two types. First is aromatic and second is anicyclic. What are aromatic compounds? When we go to general organic chemistry, in general organic chemistry, we will deal with this aromaticity, right? But here I will provide definition of aromatic compounds. What are aromatic compounds? If any compound satisfies these functions, we call that compound to be aromatic. The compound must be, first point is that any compound is said to be aromatic if it is cyclic and planar. Second point, each carbon of that compound must be sp2sp hybridized. Third point, the total number of pi electrons must be equal to must obey Huggle rule. I can say 4n plus 2 is 4n plus 2 pi electrons. It should obey, where n is an integer 0, 1, 2, 3, 4. I will repeat it. What is the first point? Compound is said to be cyclic when it is cyclic and planar. Aromatic when it is cyclic and planar. Any compound is said to be aromatic if it is cyclic and planar. What is the second point? Each carbon of the ring must be sp2sp hybridized with closed conjugation. What is the third point? The compound should obey Huggle rule. What is Huggle rule? 4n plus 2 pi electron rule. And n equal to 0, 1, 2, 3, 4. Clear? Please write it down. Aromatic. Aromatic. Conditions. What are the conditions for aromatic compounds? Conditions, right? First condition, write it up. The compound must be cyclic and planar, or it must be cyclic and planar. Cyclic and planar. Right? What was the second point? What was second point? हर कोई कार्बन एटम इसमें क्या होना चाहिए? sp2 या sp होना चाहिए, और उसमें कौन सी कंजुगेशन होनी चाहिए? क्लोज्ड कंजुगेशन. Each carbon atom must be as usually sp2 react sp also, right? sp2 hybridized with closed conjugation What is the third point? It should obey Huggle rule. It's the third point. It should obey Huggle rule. We have to go through this aromaticity in detail, right? But in GOC, general organic chemistry, it should obey Huggle rule. What is Huggle rule? It is 4n plus 2 pi electron rule. n किसके बराबर होना चाहिए? बोले है ना? It should be these are aromatic compounds. For example, let me take an example of benzene. Is it benzene? Double bond, single bond, double bond, single bond, double bond. Clear? Is this compound cyclic and planar? Why? Because each carbon is sp2 hybrid. First of all, it is cyclic compound and planar. Each carbon is sp2 hybridized. 1 pi bond, 1 pi bond, 1 pi bond. Each carbon is sp2 hybridized. Clear? 4n plus 2 equal to how many pi electrons are present? There are 3 pi electrons present. That is 6 electrons. 4n plus 2 equal to 6. 4n equal to 6 minus 2 equal to 4. n equal to 4 upon 4 equal to 1. And it's an aromatic compound. Right? So what are the conditions for a compound to be aromatic? Any cyclic compound can be aromatic if it satisfies the following conditions. What is the first condition? The compound must be cyclic and clean. Second point is each carbon atom of the ring, cyclic ring, must be sp2 hybridized with closed conjugation. And what is the third point? It should obey Huckel rule or polar plus 2 pi electron rule where n is equal to, right? And I give an example of benzene. Now we will go through this types of aromatic compounds, then we will be dealing with this, right? Second is benzoate aromatic compounds. Benzoate aromatic compounds. Is benzene homocyclic or heterocyclic? Benzene is just like this. Each member of the ring is carbon. When each member of the ring is carbon, it is a homocyclic, right? So all benzoate aromatic compounds are homocyclic. What is homocyclic? When each member of the ring is carbon, right? So what are benzoate aromatic compounds? Benzoate aromatic compounds are those aromatic compounds if they contain at least one benzene ring. Write it down. Compounds containing at least one benzene ring. At least one benzene ring. मिनिमम एक रिंग होनी चाहिए बेंजीन की, उनको बेंजोएट एरोमेटिक कंपाउंड्स कहा जाता है. बताइए एग्जांपल. What is the name of this compound? Is it benzene? What is this compound? In aromatic hydrocarbons, when we go to the nomenclature, we have gone through this, right? This is naphthalene. Right? If three benzene rings are joined together, is that anthracene? Yes. And this compound is anthracene. Clear? What's the name of this compound? Phenanthrene. See, every compound contains benzene rings. यहाँ एक बेंजीन रिंग है, यहाँ दो है, यहाँ तीन है, वहां भी तीन है. तो इन कंपाउंड्स को हम कहते हैं बेंजोनाइड एरोमेटिक कंपाउंड्स. क्लियर? It will be followed by non-benzoate aromatic compounds. Non-benzoate aromatic compounds. What are non-benzoate aromatic compounds? क्या होते हैं? कौन से कंपाउंड्स ऐसे जिनको non-benzoate aromatic compounds कहते हैं? Any aromatic compound if it does not possess a benzene ring. कोई भी ऐसा कंपाउंड जिसमें बेंजीन रिंग नहीं होगी लेकिन एरोमेटिक है, that is non-benzoate aromatic compound, right? But aromatic compound without a benzene ring, aromatic compound without any benzene ring, any बेंजीन रिंग. हमें ढंग से ये पढ़ना, क्योंकि जब मैं जीओसी स्टार्ट करूंगा पहला टॉपिक में इलेक्ट्रॉनिक इफेक्ट्स, दैट विल बी फॉलोड बाय एसिड बेस कैरेक्टर, कार्बाइन आयन, टाटोमेरिज्म, एंड एट लास्ट वी विल गो थ्रू दिस एरोमेटिसिटी. क्लियर? मैं यहाँ कुछ कंपाउंड्स बताता हूँ जो नॉन बेंजोनाइड है. ये एरोमेटिक क्यों है, हमने कैसे कंडीशंस हम देखनी पड़ेगी, ये एरोमेटिक है क्यों है, क्या कंडीशंस है, वो हम एरोमेटिसिटी में ही पढ़ेंगे. राइट। देखिए मैं कुछ एग्जांपल दूंगा। This is a compound. And this compound is called azulene. It is an aromatic compound. It does not contain any benzene, therefore it is non-benzoyl aromatic compound. It is cyclopropynyl cation. Next, it is cyclobutynyl dication. Clear? It is cyclopentadienyl anion. It is tropolo. This compound is called tropolo. Heterocyclic aromatic compounds. What are heterocyclic aromatic compounds? Heterocyclic aromatic compounds are those aromatic compounds in which the ring contains heteroatom. Instead of carbon atom, there is presence of heteroatom. The heteroatom may be in the form of oxygen, nitrogen, or sulfur. Right. When at least one member of the ring is heteroatom in the form of either nitrogen, oxygen, or sulfur. Nitrogen, oxygen, or sulfur. Its first example is pyridine. Clear? Second is pyrrole. Pyridine, pyrrole. Next is when we place oxygen in place of nitrogen, and we call it as furan. Iopine, furan, thiopine, It is quinolene. Clear? So we have completed this aromatic compounds, both homocyclic as well as heterocyclic. Right? What are heterocyclic aromatic compounds? These are those aromatic compounds when at least one member of the ring, aromatic ring, is a non-carbon. The non-carbon may be in the form of nitrogen, oxygen, or sulfur. I mentioned every example. This is pyridine containing nitrogen as non-carbon, pyrrole containing nitrogen as non-carbon, furan containing oxygen as non-carbon, thiophene containing sulfur as non-carbon, and quinolene containing nitrogen as non-carbon. Right? After that, we will go to alicyclic compounds. What are alicyclic compounds? Alicyclic compounds. Alicyclic compounds. These are the compounds which are aromatic but not. These are the compounds which are cyclic compounds but not aromatic. Right? But cyclic compounds but not aromatic. Short name. Cyclic compounds but not aromatic. But not aromatic. Clear? कोई भी साइक्लिक कंपाउंड एलिसाइक्लिक तभी हो सकता है जब वो एरोमेटिक कैरेक्टर पोजेस नहीं करता. इनके एग्जांपल क्या है? देयर अदर आर टू टाइप्स, होमोसाइक्लिक एंड हेटेरोसाइक्लिक. फर्स्ट ऑफ ऑल आई विल टेक होमोसाइक्लिक. होमोसाइक्लिक एलिसाइक्लिक compounds. What are homocyclic aromatic compounds? Those compounds which are not aromatic but each member of the cyclic ring is a carbon. Right? जब ऐसी cyclic ring जो aromatic नहीं है लेकिन हर कोई कार्बन रिंग का, हर कोई एटम जो का ये रिंग का है वो कार्बन है. क्लियर? When each member of the ring is carbon. When each member of the ring is carbon. No talking. When each member of the ring is carbon. For example, it is cyclopropane. In nomenclature, we will go through them. It is cyclobutane, cyclopentane, cyclohexane. Right? Yeah, this compound is 1-cyclohexane. These are the examples of homocyclic, alicyclic compounds. Next is heterocyclic, alicyclic compounds. What are heterocyclic, alicyclic compounds? When each member of ring is not carbon, but instead of carbon there might be present heteroatom in the form of nitrogen, oxygen, or sulfur. Clear? When at least one member of the ring is non-carbon. For example, let me take an example of oxirane. It's called oxirane or epoxyethane. Epoxyethane. Okay. Second is it is oxetane. It is oxygen. Next compound is just like this. It is pyrrolidine. This was I have rubber. It's pyrrolidine, right? What about this compound? This compound is called THF. What is THF? Tetrahydrofurane. What is it? THF. THF is tetrahydrofurane. What about this compound? It is dioxane. And these are a few examples of heterocyclic, alicyclic compounds. I will write here one more point in note. Important point. An open chain compound is it visible? An open chain compound can never be aromatic. But an open chain compound can never be aromatic. जब भी कोई ओपन चेन कंपाउंड होगा वो कभी भी एरोमेटिक नहीं हो सकता. तो ये हमें थोड़ा सा क्लासिफिकेशन था. How we can classify the organic compounds? Organic compounds are classified into following types. First classification is the compound might be open chain or acyclic compound, or it might be corrosion chain or cyclic compound. What are open chain or acyclic compounds? Those compounds which do not contain any cyclic structure. They may be straight chain or branch. What are closed chain or cyclic compounds? When the organic compound is in the form of a cyclic ring, they are called closed or cyclic compounds. Closed or cyclic compounds are further classified into following types. What was the main classification? Alicyclic, aromatic. What are aromatic compounds? Further conditions for a compound to be aromatic. First condition is it must be cyclic and planar. Each carbon must be sp2 hybridized with closed conjugation. It should obey Huckel rule, 4n plus 2 pi electron. Right? Then aromatic compounds are differentiated into two types: benzenoid aromatic, non-benzenoid aromatic. What are benzenoid aromatic compounds? Those aromatic compounds which contain at least one benzene ring. What are non-benzenoid aromatic compounds? When in case of an aromatic compound, there is not present any benzene ring. Then, what are heterocyclic, homocyclic aromatic compounds? Benzenoid or homocyclic aromatic compound when each member of the ring is carbon. Now, what are heterocyclic aromatic compounds? In case of any aromatic compound, if at least one member of the ring is heteroatom. Heteroatom may be in the form of nitrogen, oxygen and sulfur. उसके बाद क्या बताया था मैंने? Alicyclic compounds. What are alicyclic compounds? Cyclic compounds but not aromatic. जब कोई भी cyclic compound है वो cyclic ring के फॉर्म में है लेकिन वो aromatic नहीं है, उसे क्या बोलते हैं? Alicyclic compound. Alicyclic compounds are further differentiated into two types: homocyclic and heterocyclic. What are homocyclic? When each member is carbon of the ring is carbon. Now what are heterocyclic compounds? When at least one member is a non-carbon. And I have mentioned the example of all. Now it will be followed by most important topic, that's homologous series. What is homologous series? Right? Homologous series. No doubt. What is homologous series? Homologous series is a series of compounds. In which all members can be represented by same general formula. एक सीरीज ऑफ कंपाउंड, जिस सीरीज ऑफ कंपाउंड्स में जितने मेंबर इस सीरीज में आएंगे सबको रिप्रेजेंट करेंगे सेम जनरल फार्मूला से, उसे होमोलोगस सीरीज कहा जाता है. क्या? एक ऐसी सीरीज ऑफ कंपाउंड जिसमें सारे मेंबर इस सीरीज के उनको रिप्रेजेंट किया जाता है सेम जनरल फार्मूला. When each member of the series can be represented by same general formula, it is homologous series. Please write it down. A series of compounds in which all the members can be represented by same general formula. Now, what are the characteristics of homologous series? Characters of HS. What is HS?
Homologous series.
Homologous series. बताइए पहला कैरेक्टर क्या है? What is the first character of homologous series? Each member of the, I will repeat each and every point, then we will write them down. Each member of homologous series differ by one CH2 group. Let me explain this point. Each member of homologous series differ from each other by SCH2 group. What does it indicate? हर कोई member, if there are 3 or 4 members, I will give example after that. As soon as I will be done with these points, the individual members of homologous series, they differ from each other by one CH2 group. That means there is a difference of one carbon atom and 2 hydrogen atoms. Clear? Second point is that what is the atomic mass of carbon? 12. Atomic mass of hydrogen 1. Carbon 1 atom, hydrogen 2 atom. 12 plus 2, 14. I can say the second point is that the individual members, each member of homologous series differ from each other by 14 mass units. What is the next point? I can say just like this: two consecutive members differ from each other by 14 mass unit. Why 14 mass unit? Because carbon has atomic mass 2, hydrogen 1, 2 into 1,
14.
It's 14. Okay? What is the third point? Third point is, in case of homologous series, if the functional group is present, it must be same. What? अगर homologous series में functional group है, वो हर एक member में same होना चाहिए. Clear? Third point is, functional group, if present, must be same in each member of homologous series. अगर फंक्शनल ग्रुप प्रेजेंट है तो होमोलॉगस सीरीज का हर एक मेंबर में वो सेम होना चाहिए. व्हाट इज द नेक्स्ट पॉइंट? जितने भी मेंबर है होमोलॉगस सीरीज में, उनमें जो जनरल मेथड्स ऑफ प्रिपरेशन है बनाने के वो सेम होते हैं. क्या? all the members of homologous series have same general methods of preparation. Next is, all the members of homologous series have same general methods of preparation. Have same or similar general methods of preparation. Point is, what is that? They possess similar chemical properties similar chemical properties but different physical properties. Different physical properties. Let me explain this point. When they have same functional group, their chemical properties are same. When they have molecular mass different, their physical properties are different. Get it? These are the characteristics of homologous series. Now, I will give you a few examples of homologous series. For example, in alkanes, what is the first member of alkane family? Is it CH4? Second member, C2H, 6 or 8, C3H, 8. Clear? See the difference between two consecutive members. The first point is that each member of homologous series or the two consecutive members of homologous series must differ by CH2 or 14 mass unit. What is the difference between them? 2 carbon, 1 carbon, it is carbon. 6 minus 4, is it CH2 unit?
Yes.
Or atomic mass is 12 plus 2, it is 14 mass unit. Clear? See the difference here. How many carbon? 3. How many carbon? 2. What is the difference? 3 minus 2, is it 2? Is it 1? Clear? 8 minus 6,
2.
2. Or it is 14 mass unit. Clear? Next we will take the example of alkenes. Alkenes. What is the first member of alkene family? How many carbon atom may be present? That's 2. Right? Minimum 2. Clear? And the compound is C2H4. C3H. How many hydrogens are present? CH2 formula H6. C4H8. Right? See the difference. 3 minus 2, it is 1 carbon. 6 minus 4, it is 2. CH2 or 14 mass unit. See the difference here. Again, 4 minus 3, it is 1 carbon atom. 8 minus 6, it is 2 hydrogen atoms or 14 mass unit. Alcohols. Alcohol. First member CH3OH. Methyl alcohol. Second is ethyl alcohol. C2H5OH. Right? See the difference. How many carbon atoms are present in ethyl alcohol? 2. In methyl alcohol 1. Difference is 1 carbon atom. How many hydrogen? 5 plus 1 6. 3 plus 1 4. And the difference is 2. And it will be 14 mass unit. So this was homologous series. क्या है homologous series? ये एक series of compounds होता है जिन series of compounds को represent करेंगे same general formula से. Clear? जैसे मैंने पहला एग्जांपल लिया एल्केन का, जनरल फार्मूला है CnH2. सेकंड क्या लिया? एल्कीन का CnH2. तीसरा क्या लिया? अल्कोहल का CnH2n+1OH. राइट? फिर उसके बाद हमने पढ़े कैरेक्टरिस्टिक्स ऑफ होमोलोगस सीरीज. तो पहला कैरेक्टर क्या था? हर एक कॉन्सेक्यूटिव मेंबर होमोलोगस सीरीज का वो किससे डिफर होता है? CH2 से. सेकंड पॉइंट क्या था? हर एक कॉन्सेक्यूटिव मेंबर होमोलोगस सीरीज का डिफर होता है 14 मास यूनिट से. तीसरा क्या था? होमोलोगस सीरीज में अगर फंक्शन ग्रुप है वो सारे मेंबर में सिमिलर होना चाहिए, वो डिफरेंट नहीं होना चाहिए. अगर डिफरेंट होगा फार्मूला चेंज हो जाएगी, जनरल फार्मूला, तो होमोलोगस सीरीज नहीं रहेगी. नेक्स्ट पॉइंट क्या होता है? इनमें सिमिलर जनरल मेथड्स ऑफ प्रिपरेशन होते हैं. नेक्स्ट पॉइंट क्या बताया? केमिकल प्रॉपर्टीज सेम होती है, फिजिकल डिफरेंट होता है. राइट? So what are the characteristics of homologous series? The first character is that the two consecutive members differ from each other by one CH2 group. Second is the two consecutive members differ from each other by 14 units. What is the third point? If functional group if present must be same each and every member of homologous series. Next, all the members of homologous series can be represented by similar general formula. Next point, they possess similar chemical properties but different physical properties. Today we will conclude here, and in next lecture we will start from nomenclature of organic compounds.